Last lesson, you learned how to solve a system of equations with substitution. You took the equation that equaled x or the equation that equaled y, and you put those into the other equation and solved. This time you have two equations and you're going to use elimination, the elimination method. It's supposed to be a highlighter. The elimination method. Okay? So we're going to do the first pair of equations using elimination with addition. Now what this means is you're going to add the two equations and get rid of one variable. Let's take a look at this. You've got 2x plus y equals 10 and negative 5x minus y equals negative 19. Now when you're going to eliminate, you're looking for variables that have the same coefficient. Doesn't matter what it is. You want it the same though, with opposite signs. So when you add them, you will zero them out. They will go away. Let's take a look. 2x minus 5x equals negative 3x. We're just going to add straight down, just like old-fashioned addition you learned in elementary school. Well, positive y minus y is 0y. So that goes away. We have eliminated it. And that equals 10 minus 19 is a negative 9. Divide both sides by negative 3 to find my x value. X equals 3. All right. Now, we're going to take the x value and we're going to put it in to find the y value. It doesn't matter which equation you use. You're going to get the right answer with both of them. I'm going to choose the top equation. I'm going to substitute. So I'm going to say 2 times 3, because that's my x, plus y equals 10. 2 times 3 is 6. Let's make that nicer. 6 plus y equals 10. Subtract 6 from both sides, y equals 4. And as I told you last lesson, use the other equation to check your answer. Since I used 2x plus y equals 10 to find the value of y, I'm going to use the other equation, negative 5x minus y equals negative 19, to make sure my math works. So let's do that. Negative 5 times 3, because I'm substituting, I'm replacing, let's not use that word. I'm replacing my x and my y with the values that I found. Let's see, y is, oh, that's a minus. My apologies. If I was perfect, you wouldn't recognize it was me. 4 equals negative 19. All right? 3 and 4 are replacing the x and the y. So let's do the math. Negative 5 times 3 is negative 15. Minus 4 equals negative 19. Negative 19 does equal negative 19. We did the math right. So if we came out with a statement that didn't make sense, that means we did something wrong and we would have to go back and check. Let that sink in the brain. All right, let's look at solving a system using multiplication and addition. You are not always going to have equations like the top where you've got everything lined up all pretty and perfect. It's just not going to work that way all the time. So you are going to have to do some switching around. You're going to look at your two equations. Now look at these two equations. You've got negative 2x and negative 5x, and you have negative 9y and negative 3y. Now you need to have solid multiplication facts in your head. You need to know your factors. Because you can see that negative 9y and negative 3y are kind of similar. I can multiply negative 3y up to 9 That's not a big deal, is it? So I'm going to multiply this bottom equation. I'm going to make the y's match. All right? So what that means is I'm going to multiply both sides, the entire equation. Now I do this to remind me I'm doing both sides by 3. I want my y's to have the same number, the same coefficient. But I also want them to have opposite signs. So I'm going to multiply this entire bottom equation by -3. Let me show you what it looks like when I'm done. Okay? It looks like 15x plus 9y equals 70. No, sorry. I'm doing this in my head. Equals 48. Okay? I have taken this second equation and I have multiplied it so I can get rid of my y's. I can match my y's. That's what I did. So now, if you look, my y's, I'm going to scratch through this one just a little bit. My y's now match. I have a positive 9y and a negative 9y. So let's add. We have negative 2x plus 15x, which gives me 13x. My y's cancel out. Negative 9y plus 9y is 0y. And 17 plus 48 is 65. Divide both sides by 13, and x equals 5. All right, let's find the value of y. I'm going to take my x value and I'm going to put it into the first equation. I'm going to erase my marks up here because you saw what we did. So now I'm just going to erase them so you can see the equations clearly, okay? Doesn't change what we did. It just makes it easier for you to see what we're doing. If I was on a whiteboard, I would do this too. All right. So let's write. Negative 2 times 5 minus 9y equals 17. Negative 10 minus 9y equals 17. I'm going to add 10 to both sides. Negative 9y equals 27. Divide both sides by negative 9. And y equals 3. Okay, now we're going to check it. To check it, you use an original equation. Don't use the multiplied equation. Use the original version of that equation. Okay? Running out of space here. Negative 5 times 5 minus 3 times 3 equals negative 16. Negative 25 minus 9. Oh, silly me. Mrs. Gates made an error. Guys, you're used to it. I divided 27 by negative 9 and I forgot my negative sign. Watch that. You know I made those mistakes before. There we go. Equals negative 16, and negative 16 equals negative 16. And you know how I found that little negative error? I put the numbers in the equation to check, and that's how I found the error. Okay, so checking really does save you. It helps you find the errors. So my final answer is x equals 5, y equals negative 3, and that's how we solved it. Now we're going to do another one. Now this one, let's take a look on number 2. You've got a 4x and a negative 7x. You've got a 3y and a negative 4y. There is no way for me to multiply just one equation to make them match. We are going to have to multiply both. We're going to have to multiply both equations. So at this point, you choose. Do you want to make the x's match and eliminate them, or do you want to make the y's match and eliminate them? It's your choice. I'm going to go for the x's. All right, let's take a look. So I've got a 4x and a negative 7x, and I'm going to go for the x's. They've got opposite signs. That's good. What is a multiple they have in common? Well, 28. I actually multiplied them together. So this entire equation has to get multiplied by 7, and this bottom equation has to get multiplied by 4. Now remember, I put the numbers on both sides of the equation just to help me remember to multiply the entire thing. It's a Mrs. Gates thing. Okay, I'm going to rewrite my equations, rewrite both of them. 28x plus 21y equals negative 7. And negative 28x minus 16y equals negative 8. Those are the new equations I'm using. Okay, those are the new ones. I'm still going to proceed the way I did. Now, if you notice, my 28x and my negative 28x will cancel out. So I'm just left with 5y equals negative 15. Divide both sides by 5. Y equals negative 3. I didn't miss a sign this time. All right? You're going to look at your two original equations. You are going to choose which variable to eliminate. It is a choice. And then you are going to multiply each equation so you can make the variable match. I decided to do my x's. I multiplied each equation so my x's would be eliminated and the rest of it just went along. I have my y value. I'm going to plug my y value into the top equation, the original equation, not the new one. So 4x plus 3 times negative 3 equals negative 1. 4x minus 9 equals negative 1. Add 9 to both sides, and I get 4x equals 8. Divide by 4, x equals 2. I'm still going to check it, because remember what happened with the last one? I found an error. So I'm going to use the negative 7x minus 4y equals negative 2 equation. Why am I going to use that? I haven't used it yet. It's kind of a brand new equation. So let's rewrite and include my new variables. 7 times 2, negative 7, minus 4 times negative 3 equals negative 2. So we have negative 7 times 2 is negative 14. Negative 4 times negative 3 is positive 12. Negative 2 equals negative 2. Not so bad. All right. All right, this second page of notes, still of unit 3 day 3. You're going to solve them, but then you're going to decide if the system has no solution, a unique solution, or infinitely many. If the system has no solution, it means these lines are parallel. Remember, these are actually linear equations. They're graphable equations. So if the lines have the same slope, they are parallel. If they are parallel, they will never intersect, which means the system has no solution. A solution is when the lines intersect. Now, if the lines intersect at one point, they're going two different directions, but they intersect at one point, that is a unique solution. There is one number, one coordinate point in the universe that fits both equations. You're also going to get another one where the system has the system has infinitely many solutions. That means they are the same linear equation. They're just written differently. So let's do the math, and then we're going to choose the solution. All right, so let's take a look. Well, something we can do right here, you're going to have to choose which way to do it. Let's go for easy. That's what we want. If you notice, you have a positive y and a negative y. Let's add them together and eliminate the y's. So much easier. So we have negative 6x equals negative 12. Divide both sides by negative 6. X equals 2. Let's plug in x and find the y. I'm just going to take the top equation. Negative 3 times 2 plus y equals negative 6. Negative 6 plus y equals negative 6. Add 6 to both sides. Y equals 0. Folks, 0 is a valid number. We get so used to not having 0 as an answer that we forget 0 is a legitimate number. 0 is a point on a coordinate plane. All right? This is okay to get a 0. So let's make sure I'm right, because you know we do that. I'm going to plug this into the other equation. Negative 3 times 2 minus 0 equals negative 6. Negative 6 equals negative 6. All right. I have one point. I have a single x and a single y. So the system has a unique solution, and the solution is 2, 0. That is where these lines will intersect. All right, let's look at the next one. Okay, now this one, oh, this is intriguing because you have to do some algebra to get them set up differently. You've got 5x equals negative 5 plus y, and you've got negative 5x plus y equals negative 5. You cannot add them right now to eliminate because they are not lined up. You don't have things in the same position. You can't even do substitution. Nothing's in the same position. Well, I'm going to rewrite this top equation. I'm going to line up my 5x's. Why? Why not? So I'm going to move my y, minus y, minus y, 5x minus y equals negative 5. All right, so here we go. Now look at these equations. You've got negative 5x plus y equals negative 5. Well, I can eliminate, can't I? Look at them. I've got a positive 5x and a negative 5x, so I can add those together, and I can eliminate them. Let's do that. Okay, 0x. Wait a minute, I've got a negative y and a positive y. Okay, plus 0y equals negative 10. 0 equals negative 10. Is that a true mathematical statement? It is not. It is not a true mathematical statement. 0 plus 0 doesn't equal negative 10. The system has no solution. These are actually parallel lines. The system has no solution. Okay, so you are sometimes going to get a mathematical answer that appears to make no sense, but it does, because it's telling you there is no solution. Do not try to force the numbers to go where they're not going to go. Do the math, let the math tell you what the answer is. All right, let's do the last one. We have a negative x equals 4y minus 8, and we have an x plus 4y equals 8. Well, let's move things around. I'm a big fan of elimination. It's my big thing. All right, I'm going to line things up. So I'm going to rearrange the top equation. I'm going to move my 4y. So I have negative x minus 4y equals negative 8. And the original equation is, the second one is x plus 4y equals 8. So everything's lined up nicely to eliminate. All right, negative x plus x is 0x. Negative 4y plus 4y is 0y. Negative 8 plus 8 is 0. 0 equals 0. Does 0 equal 0? Yes. 0 equals 0. Now what you have here is infinitely many solutions. Any value of x or y will work. They are the same linear equation. Let me show you something. Let's see, let's do it in this color. I'm going to show you what. Let's take negative x minus 4y equals negative 8 and multiply it by negative 1. Now, I'm just going to show you something. You get x plus 4y equals 8. This is the same equation as that. They are the same line. So the system has infinitely many solutions. Now this second page is what you're going to find in Alex. This is what you're going to have to do. You're going to have to do the math and determine if the system has a unique solution, no solution, or infinitely many solutions. All right, we've got some good examples here.